I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, week starting Sunday, January 8th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. All right, let's get to work. We start by looking at significant wave heights for the North Pacific Ocean. We see a broad area of seas 18 to 22 feet, pretty much filling the entire North Pacific. A very agitated sea state is in play, focused mainly on the East Pacific, driven by a strong jet stream and lots of just non-stop storm activity pushing due west to the east right at the U.S. West Coast. Looking at buoys up and down the California and Hawaii coast, we're going to take just a quick inspection here. This graph right here represents all the energy hitting any one individual buoy. In this case, the Point Reyes buoy, Northern California, 029. It updates every half hour. Up here, the longest period energy, 33.3 second period. That's very powerful energy. There's a tenth of a foot of that energy, so not really anything. Most energy focused in about the 12 to 13 second period range, with a whole bunch of local wind swell intermixed. Pure swell, primary swell, 6.6 feet at 12.5 seconds. That roughly represents surf at about 8.3 feet. Then a bunch of wind swell mixed in. You can see the calculated surf height pattern for the past couple of days. The tail end of the massive swell earlier in the week. Another pulse of swell a day or two ago. And now things settling down into about the 8-9 foot range surf-wise. Down in Southern California, East Santa Barbara buoy, 46053. This is tucked in a little bit, not one of the outer buoys closer to shore. Gives a better representation of what's actually going on near shore. We see a little bump of energy right here at about the 14 second period range with a bunch of wind swell intermixed. Pure swell, 3.7 feet at 13.1 seconds from 275 degrees, pretty much unobstructed. Surf from that swell about 4.8 feet. And yeah, that's about what it looks like, head high, something like that. And then we go to the other extreme, the south end of Southern California, Point Loma buoy, 191. Again, updates every half hour. Bump of energy at about 13 seconds, a little something at 18 seconds, and a whole bunch of wind swell mixed in. Primary swell, 4.4 feet at 13.1 seconds. Surf from that about 5.8 feet. There might be a little bit bigger. I thought I saw some sets in maybe the 1 to 2 foot overhead range, something like that. So that's doing pretty close. And then on the North Shore of Hawaii, Waimea Bay buoy, number 106, again, a seated buoy, updates every half hour. Bits of energy, but things winding down pretty much there. Energy scattered between 15 seconds and about 8 seconds. Primary swell, 2.5 feet at 11.7 seconds. That's 3 foot Hawaiian, chest high, shoulder high, something like that. And that's about what it looks like. All right, so what's going on? Let's take a look at the upper atmospheres first. Jet stream level winds, 30,000 feet up. These winds help support the formation of gales. When they form, help direct their track. We're looking for a trough, a dip in the jet. Why? Well, because we see a little one right there, another one right there. These dips in the jet help create an eddy, a counterclockwise flow in the upper atmosphere and down at the ocean surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface and generate seas, and seas, as they radiate away from the fetch area, turn into swell. Swell and hit your beach at Hawaii or the U.S. West Coast, turns into surf. So we have a little bit of a start of a trough here off the Kuril Islands. That's Kamchatka, Kurils, Japan there, Aleutian Islands, and California down here, Alaska, Canada, you get it. The jet stream, very strong, completely consolidated, and raging from west to east on about the 35 north latitude line. Maybe not quite as strong as it's been the past week or so, but still 160, 170, almost 180 knots in pockets. And this is what has been contributing to just the nonstop onslaught of weather coming into California. Precipitation, much needed. Snow in upper elevations, though, tending to be a little bit more on the wet side than the dry side. A total pattern change from earlier this year when the jet was ridging way up here and then diving south down the coast, dragging cold air with it and making for lighter snow. But this is just a bulk precipitation wet maker, making for mud and landslides and all kinds of crazy stuff going on into California. But that said, filling up the reservoirs and very much needed. All right, let's put this into motion. As we get into Monday, here we go. Another trough starting to really dig out, being fed by 190 knot winds off the California coast. That second trough trying to develop north of Hawaii. So we get into Tuesday, there we go, deeper here, deeper here. This looks like a huge weather maker again for California. So we get into Wednesday, the first pulse of that pushes onshore. Another trough digs out in the Gulf of Alaska. This is Wednesday, January 11th. Another system starts developing off the Kuril Islands. As we get into Wednesday, just big low there, little bit of ridging over California and maybe a little bit of a dry out. But Thursday, look at this, 100 and 210 knot winds diving down into this trough. That's a little bit steep, kind of makes it difficult for a low to form. It's still likely a weather producer. Another one out here off the Kuril Islands. Eventually, by Friday, the pinch trough pushes into California. By the weekend, that same trough pushes over the dateline into the Western Gulf, and you get the general idea here. It just continues, but, and I say but, look at this. The jet starts to split. In fact, let's roll this back to right around here. Sunday, that'd be about a week from now. A split in the jet is forecast, and that suggests weakness in energy being fed to the jet. And we'll get into that long term when we start talking about MJO and the long-term outlook. But the sense is somewhere between there and there. So that is where we are today, and there, perhaps a break in the weather pattern is setting up for California about a week out, maybe a little bit more. Right, so let's go take a look down at the surface. Surface level pressure, surface level winds. Right now, we see just a broad area of low pressure with multiple embedded low pressure systems in that with 30 to 35 knot fetch. You saw the significant wave height image a little bit before, just 18-foot seas filling this whole area. And then a more standalone gale, actually a storm. It almost looks like there's some 55 knot winds trying to develop there. So much activity over the ocean. As we get into Monday, you can see it here. This broad system starts pushing into the U.S. West Coast. A storm develops on the dateline, 55 knot winds. Now, Hawaii's right here, but most of this energy aimed off to the east. As we get into Tuesday, the storm continues. A little bit better aim at Hawaii, but due north of the Hawaiian Islands, just general momentum would suggest most of the swell probably targeting more out in this direction. Big low, again, getting ready to move on to the California coast, does that on Tuesday. And then the big system continues, starting to bypass the Hawaiian Islands Tuesday night. New system develops off the Kuril Islands. You can see them just, look at this, two massive storms or gales filling the entire North Pacific. You would think this fetch will get significant traction on the ocean surface and much seas and swell would be generated. But the issue is, certainly if you've been in Northern California, it's just too much of a good thing. The swell's just overlapping on top of one another, too close to the coast. Lots of short period energy mixed in and south winds, and it just turns into a giant jumbled mess, and none of it really surfable except at the most protected breaks. As we get into Friday, things start to dissipate off the California coast. Broad low pressure over the North Dateline region, still producing fetched aimed at Hawaii and the U.S. West Coast. But then here we go on Saturday. Another little system tries to, look at that, just dives right into California. And then things mellowing out off to the west. But there we go on Sunday, another broad system developing, but more to the north, displaced a bit, maybe suggesting that pattern change that we were talking about in the jet stream. That the net result of that would be, we think storms will be focused more out here in the West Pacific to the dateline and Western Gulf, and things, maybe a ridge will build over California long term. Just purely a guess, and a chance for things to dry out, but even more importantly from surf perspective is high pressure setting up, less south winds, maybe light offshores, or at least a calmer wind pattern, and better opportunity If the storms are out here, the resulting swells get chance to get groomed, come into the coast, and much less jumble in the water. All right, significant wave heights for the next week. We're not even going back in time because it's just this steady, just jumbled, massively upset sea state out here in the Gulf of Alaska. That will take days to settle out before things, if there was literally no activity at all from here on, there'd probably be swell for 4 days before things really started to settle down. Anyway, we get into Monday. Certainly not a calm state. Expect another gale building off the California coast. Storm building over the dateline with 41-foot seas. Building as we get into Tuesday right here. 44.7 feet, the highest seas in this entire domain right there. And I think they even go a little bit higher, 46 feet. And maybe, oh, there we go, 48 feet on Tuesday night. Now notice, the core of this fetch, or these high seas, are actually east of Hawaii, and most of the fetch is all aimed off to the east. So the target, U.S. West Coast, again, Hawaii getting sideband energy, still certainly some decent size expected, but maybe not quite as big as one would completely expect, just blindly looking at the colors here. Anyway, the system, the first storm, actually this would be, I think, the second significant class storm. There's been a lot of surf and jumbledness, but this is probably what we're going to call a significant class swell. The second one of the season, aimed right at the U.S. West Coast. Probably a third one developing behind that. Just 20-foot seas filling the eastern Gulf of Alaska, slamming into the U.S. West Coast. Friday, more of the same. Things settle down a little bit as we get into Saturday. And Sunday, actually things look like they might calm down, but then here we go. Here's another one. The hope is a little bit of a ridge builds over California to sort of settle things down a bit, so we end up with more groomed swell rather than just a pure raw storm surf sort of state. Local wind forecast Sunday. Well, you can see it right here. Massive low pressure, south winds just from Point Conception northward, pretty much a jumbled mess. Hawaii sits in a weak trade wind pattern. That's actually pretty good. As we get into Monday, here's the next front, 30-knot north winds from Point Conception south winds from Point Conception northward, and trades 10 knots or so for the Hawaiian Islands. So we get into Tuesday, more of the same, 30-knot south winds off the coast, 55-knot winds north of Hawaii, but Hawaii sits with maybe a little bit of a front and some sort of south wind thing going on, but not too bad. As you get into Wednesday, then here is a bit of the issue for Hawaii. The trades dissipate. You end up with a front coming through and north winds about 10 or 15 knots for the Hawaiian Islands, where still south winds for the U.S. West Coast, north of Point Conception. More of the same as we get into Thursday, but trades finally kick in for the Hawaiian Islands. On Friday, more south winds for California, trades for the Hawaiian Islands. Saturday, yet more of the same, though notice the south wind pattern weakening somewhat relative to California. Trades turn more southeasterly for the Hawaiian Islands. So we get into Sunday again. Now finally a front blows through. It almost looks like northwest winds, but we're not holding our breath. East trades for the Hawaiian Islands. We get out into, here we go, 180 hours out. Here's yet another low slamming into the coast with trades for the Hawaiian Islands. So clearly the focus from a wind perspective is either Hawaii or somewhere south of Point Conception. North of Point Conception, it will continue to be a mess for the whole week. This will set us into, 2.5 weeks or so of just nonstop onshore rainy mess, but take it however you can get it. It's better than a drought. Precip forecast for California. California right there. That's Point Conception, Southern California here. Central California, Bay Area right there. Northern California. The blue, of course, precipitation. You see the next system moving in Sunday night, tonight, into Monday, slamming snow in higher elevations for the Sierra, piles of rain down to about Point Conception, but leaching into Southern California. Look at that, very heavy snow. Storm conditions, this would be Monday night. And then as we get into Tuesday, a bit of a break And then by Tuesday morning, boom, here we go. Yet another one with rain the whole way into Southern California, into Baja. That clears out some on Wednesday. And now an interesting thing sets up. Yes, broad low pressure here, but watch where the rain line is. There's the Bay Area right there. It just sort of stalls off the coast and can't quite make it in for the better part of a few days. And then finally on later Friday into Saturday, it sort of weakly limps on shore with a little bit of reinforcements coming behind that with more snow and rain. And then on Sunday, I think we have a bit of a clear, nope, yet another pulse behind that. So it looks like a pretty soggy mess other than a 2-day break south of San Francisco. But other than that, pretty much nonstop rain. Olympic Valley snow forecast dashboard. Actually, okay, so this is a little thing I learned. Alpine Meadows is still Alpine Meadows. What was Squaw Valley is Olympic Valley, and the two of them together are Palisades Tahoe. All right, so looking at total snow accumulation, you can see here's the first pulse of the storm, you get 2 feet. Second pulse of the storm was this like a Tuesday, Wednesday, you get another 2 feet, and then some more coming next weekend, and we're somewhere up over 100 inches of snow. Now this is probably a bit overstated because temperatures, again, the jet stream slamming right in, temperatures are not as cold as they would. The freeze level is higher. If you have colder air down lower, smaller amounts of liquid precipitation can turn into greater amounts of snow. This just uses, I think it's we're using a 1 inch to equals 12 inches. 1 inch of rain equals 12 inches of snow. That might be a little bit on the high side, but anyway, you get the general idea. The freeze level for Olympic Valley. This is the base of Olympic Valley at about 6,200 feet. This is the summit at about 9,000 feet. The red is pure liquid precipitation above freezing temperatures. The gray here, the line between the gray and the white is the 32-degree freeze line. So we see a bump in temperatures coming up. In fact, we can kind of see this overlay here with the precipitation. Things get warm almost to the summit, and then temperatures plummet and snow starts building up, accumulating. Then we have another warm spurt somewhere around, was that the 12th and 13th? That would be, I think that is middle of next week. Then temperatures dropping back down with more precipitation after that. Kirkwood doing about the same in terms of the total snow precipitation, somewhere over 100 inches. But the good news here, their base is higher at about 7,800 feet, and the summit's up to like 9,800, 9,900, something like that. So the spikes in the temperature don't go as high up the mountain, maybe to mid-mountain, something like that. So a little bit better opportunity for non-liquid precipitation. And Mammoth, equally in the mix. You saw the jet stream. It's almost going to be slamming right into the Sierra where Mammoth is. So over 100 inches there as well. And by virtue of them being yet higher still with their base at 8,000 feet, summit up at 11,000 feet, yeah, still this, the first little warm spike here doesn't even make it to the base. The second one does reach about mid-mountain, but not too bad. There isn't really any snow happening during this warm spike, so not so bad. That actually will give a chance for maybe the different layers of snow to glue together a bit with the heat, and then you start dumping more snow on top of that. So all in all, wet pattern continues, snow building up, potential for reservoirs filling also improving. In fact, from a rain perspective, we just looked at San Francisco and the area, somewhere around 14 to 15 inches of liquid precipitation have fallen already in this rain season. Typical normal is 22 inches roughly, so we're at, let's say, 70% of the entire annual rainfall already, and we're only going to get better than that given the whole week of precipitation forecast ahead. This is good news. Bad news if you're in a flood-prone area, if you're into an area affected by mudslides, but purely from a reservoir management perspective, great news. All right, let's go take a look long-term. What's going on with the Madden Julian Oscillation and, of course, the El Nino Southern Oscillation. These two oscillations are the major determiners of weather and swell production for the North Pacific during winter months. We start by looking at winds across the equatorial Pacific. trade winds or the reverse of trade winds. This is all, we're looking for the active phase of the MJO, the Madden Julian Oscillation. It's this periodic weather oscillation, two phases, active and inactive phase. The active phase imparts energy to the jet stream, which then in turn feeds storm production. It also, when it's over the West Pacific, can dampen or reverse trade winds. When it does that, that results in warm water that's typically pulled up in the West Pacific, starting to slosh east in the form of a Kelvin wave. That is a ball of warm water. If you have successive active phases of the MJO, they create successive Kelvin waves. Those Kelvin waves eventually erupt on the equatorial East Pacific by the Galapagos and Ecuador, and that can create a buildup of warm water there, and that's how you start El Nino. And of course, El Nino is very good for water, precipitation into California, and storm production across the Pacific, and looks very much like exactly what is happening right now across the Pacific. The reverse of that, of course, is what we've been living through for the past 2 years. La Nina, driven by successive inactive phases of the MJO. It increases trade winds, steals energy from the jet stream, creates high pressure over both the north and southern hemisphere, and then basically you get no precipitation or decreased precipitation with the jet pushed further north, more up into the Pacific Northwest and Canada, and not down into California. And then you get a big ridge over the middle of the Pacific, and not great for storm and surf production. All right, so we're looking at the TAO buoy array, series of buoys strung across the equator. This is the West Pacific here, East Pacific here. 0 is the equator. The date line right there, that little blob, that's New Guinea. We're looking at the arrows, indicating wind direction and speed. The longer the arrow, the stronger the wind. So trades out of the east, pretty strong in the East Pacific. Same thing over the Central Pacific. Same thing over what we call the Kelvin wave generation area. The West Pacific, that is when the active phase of the MJO moves over the West Pacific, and if it reverses trade winds, creates what's known as west anomalies. See, these winds are normally out of the east. If they switch and start coming out of the west, then the warm water here starts moving to the east, all right? But it's not the actual wind speeds that matter. These are subtle changes in the wind, and it is the anomalies, the difference in wind speed compared to normal for this time of year. Look in the East Pacific, well, these winds, though they look strong, are pretty much normal. In the Central Pacific, a little bit stronger out of the east than normal. In the West Pacific, a little bit stronger out of the east than normal, suggesting the inactive phase of the MJO. But let's dig a little bit deeper. Here's another view of what's going on. 850 millibar zonal wind anomalies. That is, are the winds blowing stronger out of the east or stronger out of the west than normal? The blues are stronger than normal trades. The oranges and reds stronger than normal out of the west. But now let's get ourselves oriented. South America here, Central America here, Hawaii right there, New Guinea there, the equator right there, dateline right there, the Kelvin wave generation area right in here. We see westerly anomalies in the far West Pacific on January 2nd, pretty much continuing, mainly south of the equator, but still no real easterly anomalies in this area for the past 5 days. That suggests that maybe westerly anomalies are a little bit stronger than what the previous chart indicated. And then zonal wind anomalies for the next week. Now, this is the forecast from the GFS model, but a real obvious trend pops out here. All right, so what are we looking at? This is the east-west component of the wind for the whole planet. The date line runs right up the middle, okay? The far West Pacific starts, we'll say about 120, 125 east, somewhere like that. So the Kelvin wave generation area, the area, if westerly anomalies are in this square here, or you can just draw the line the whole way up the chart, then that can help create a Kelvin wave. All right, so on the date line, we see these strong blues and purples, easterly anomalies. But notice somewhere in December, westerly anomalies started creeping to, well, almost halfway filling the Kelvin wave generation area. Little bit of back and forth between this. Today, westerly anomalies, 155, almost 160, almost we'll say 60% of the Kelvin wave generation area filled with westerly anomalies, supposed to give up a little ground for a couple of days, and then build even stronger, filling to the date line. Now, they're just weak westerly anomalies, but this is a huge change. Notice here, there was a little pocket of westerly anomalies in early December, too. What we've been suffering through for the past 2 years is this purple blob has been filling from here the whole way to the date line and beyond, just making Kelvin wave production impossible, stealing energy from the jet stream. But as we've talked about and we've been watching, these westerly anomalies were forecast months ago to start making inroads into the West Pacific. They have done that. Notice the jet stream, what was it, 2 weeks ago, all of a sudden just went from being ridging way far in the North Pacific to boom, just like a bulldozer coming the whole way across the Pacific, and now all of a sudden we were flooded with water, more than we know what to do with, more snow than we know what to do with, and more surf than we know what to do with. Too much of a good thing, all concentrated at once. That, we believe, is attributable not only to these westerly anomalies moving into the West Pacific, feeding energy to the jet stream, but then pulses of the active phase of the MJO reinforcing that. And this is just driving a heart through La Nina and hopefully moving us towards at least a neutral ENSO pattern. All right, so let's look out 2 weeks. We have two different models to do this. First, the statistic model. This is another one of these MJO models, but this looks at cloud cover. Pretty much the same as the winds, though. If the active phase of the MJO is a low pressure system, all right, low pressure not only can help reverse trade winds on the equator, but it also creates more clouds than normal. The blue is, so this is outgoing long wave radiation, sunlight bouncing off the ocean surface. Blue means more cloud cover than normal here. One could equate that roughly with the active phase of the MJO. The reds and oranges, the inactive phase, high pressure, more sunlight reflectivity off the ocean surface. This is South America here, Central America, Hawaii, New Guinea there, dateline there, the equator there, Kelvin wave generation area right in there. So 5 days from now, per the statistic model, inactive phase making its way into the Kelvin wave generation area, building stronger and stronger. This would theoretically, this is 15 days out, 2 weeks from now, suggest the jet stream is going to lose a lot of energy. Remember when we looked at the jet stream chart about a week out, it started showing signs of weakness. That corresponds pretty well to this chart. Now the GFS model, maybe not as negative as the statistic model. It says the active phase of the MJO weak, holding for about the next 10 days, and then 2 weeks from now, the inactive phase of the MJO moves into the West Pacific and splits the jet, or we suspect will split the jet, and that'll notch the storm production down significantly. So the difference between the two models is, well, the statistic model says inactive phase coming in a little bit earlier, the dynamic model saying a little bit later. Either way, they both end up in the same place about 2 weeks from now. Phase diagrams, the same two models, statistic model here, dynamic model here, but looking at the MJO from a different perspective. Where is the MJO actually located and how strong is it? So the MJO moves from west to east, from the Indian Ocean to the maritime continent, into the West Pacific to the East Pacific. Remember, it's doing this, it rotates around the planet on the equator. Active phase on one side, inactive phase in the other. They rotate around like that from west to east. All right, from the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is today. So the statistic model says it's in the East Pacific roughly, and if it's inside this circle, it's very weak. What we really want to see is this dot like up in here. That would be massively strong MJO activity. And why would we want to see that? Well, that would suggest a lot of energy transport to the jet stream. Now, you can see just earlier in January, the active phase on the 29th of December 30th. It's just been like lingering around here in the West Pacific. Not very strong, but it doesn't take much. That combined with westerly anomalies in the West Pacific has been what's feeding the jet stream. The forecast now has there's 3 different tracks here, but all of them have the active phase of the MJO in the Indian Ocean 2 weeks from now. So the inactive phase would be on the other side of the chart up here. So inactive phase over the West Pacific 2 weeks from now per the statistic model. Dynamic model suggesting pretty much the same thing. A turn down in the volume of the jet stream and storm production 2 weeks out. The upper level model showing areas favorable for precipitation. That would be the areas in green. You can see green making its way across the Pacific. And then yellow coming in behind that. That's dry air. Areas not favorable for precipitation. The greens then would be the active phase of the MJO. The oranges, the inactive phase. And let's get ourselves oriented. There's 8 different panels here. They are each forecast 5 days into the future. So South America, Central America, 0 is the equator. The dateline roughly there. New Guinea there. Kelvin wave generation area right there. So today, the greens, wet air, active phase of the MJO, slowly slipping out of the Kelvin wave generation area by the 16th of January. And the inactive phase, you can see making its way in. Active phase, moving out of the Pacific completely by the 12th of February, inactive phase in control. But by the time we get to the end of the model, I'm looking around the camera here, 15th of February, you see the active phase starting to build into the West Pacific again. So if you were just guessing long term, I'd say, okay, we're going to get another week, maybe 2 weeks of pretty intense energy. And then as we get mid-January to mid-February, maybe a turn down in the surf production, rain production, snow production, maybe a good time to go take care of business, do whatever you got to do. And then as we get into mid-February, things ramp up again, and the machine, swell production machine and snow production machine, perhaps turns on again. All right, the CFS model going out 1 month. Same deal, the whole plan on one chart, the date line running right up the middle of this chart. Kelvin wave generation area in this area right here, or going the whole way up the chart. You can sort of see the picture here. The blues are easterly anomalies. This is the classic La Nina signal when it's just nonstop blues and easterly anomalies on the date line. The last big push was right around Christmas. Now, the solid contour is the active phase of the MJO, which has all been pretty much non-existent. The inactive phase, the dotted contour, a little bit more dominant. But notice this, here in December, big active phase of the MJO, pushing into the West Pacific with west anomalies making it to, well, about 165, maybe 170 west, just nonstop. And this is that whole time when the jet stream started raging. That's supposed to continue in some fashion. Now notice the active phase of the MJO, according to this, fades out January 9th. I think that's a little bit on the early side. You still see pretty good westerly anomalies in the West Pacific, even as the active phase fades out into February. This is a good sign. This maybe is suggesting the total and complete demise of La Nina. Let's go look at one more forecast. Now this is the CFS model going out 3 months. Past performance down here, future performance here. The date line running right up the middle. Again, the far West Pacific starting somewhere around here. Take a look at this. You can see it plain as day. The oranges and yellows are westerly anomalies. We could say the El Nino signal, but it's really not that. It's not the La Nina signal. But notice they were all over the maritime continent. Right here up until about December 15th, we started seeing signs of something going on. But then as we got into mid-December, look at this. Big active, I assume this is the active phase of the MJO here. Westerly anomalies pushing clearly into the West Pacific. exactly in sync with the jet stream just going out of control. There is definitely a cause and effect there. Now, the good news is, look at this, westerly anomalies just continuing, building further and further over the Kelvin wave generation area, filling it theoretically now by February 15th. People ask, what's the model? What did the model predict a month ago? It actually thought that we'd be in this state probably in mid-January. So the model overhypes it a bit, but nonetheless, it's still generally getting the picture correct. Let's overlay the MJO here. All right, so here we are, right smack in the middle, probably the peak of the best active phase of the MJO we've seen for at least 6 months, and that's producing the westerly anomalies. Inactive phase of the MJO sets up somewhere around mid-January into mid-February. Then another active phase of the MJO, at least on this one, hyped to make it the whole way across the Pacific. Notice this is one sort of phase as it gets to California. Whole way across the Pacific, westerly anomalies to the dateline and beyond. Strong, now this is ridiculous looking out in March, but very strong active phase of the MJO, probably producing some sort of westerly wind burst. In fact, look at this here. This actually happened, westerly wind burst in the West Pacific. That is what caused the jet stream surge that we're seeing right now, and more than likely is creating yet another Kelvin wave. We'll get more into that in a minute, but we've had one, the second here, possibly a third out here. That is how you at least get rid of La Nina, by infusing warm water into the East Pacific and knocking the trades down. And once you're in this kind of a configuration, you're not going to get enhanced trades coming back anytime soon, possibly pushing us into at least a neutral, if not a weak El Nino status as we get into late spring. And then finally, the low pass filter. That is, it's showing the general bias towards either low or high pressure. In fact, we'll pull all this out so you can just see it. The dotted contour, high pressure. This is the La Nina signal. It's been locked over the dateline. Right there's the dateline. Been locked till about Christmas time. You see the leading edge of this starting to ease off to the east. You see a steady eastward progression of it. By mid-March, it's completely out of the Kelvin wave generation area. And then the low pressure bias. This is just a propensity for just ongoing low pressure. The El Nino indicator, which has been over the maritime continent. Notice the leading edge starting somewhere around mid-December. Slowly creeping east, what we want to see, into the Kelvin wave generation area. By mid-February, it lurches radically to the east, and low pressure filling the entire Kelvin wave generation area. Now, this would be wonderful for infusing lots of energy for the jet stream for the latter part of winter, but also, if this holds true, the coming summer should be pretty good as well, because this jet stream energy is not just limited to the northern hemisphere. It does the same thing in the southern hemisphere. So in the winter months in the northern hemisphere, you get more jet stream energy. In the winter months in the southern hemisphere, which would be our summer months, you get more energy infused in the jet stream. Maybe not as tight of a correlation in the summer hemisphere, but still the net result is the same thing. Better southern hemi swells as we get into the summer. And yet one more dynamic. I'm going to remove that bias there. I'm going to remove the MJO. I'm even going to remove 850 millibar winds. I'm going to look at outgoing long wave radiation, that cloud cover thing that we were talking about earlier. So in the past, the blue is less sunlight reflecting off the ocean surface. The yellow is more sunlight. So in the Kelvin wave generation area, this suggests high pressure was in control, where low pressure was in control over the maritime continent. Look what happens as we get into starting even now. More cloudiness, completely building, filling the Kelvin wave generation area starting January 16th. This suggests a wholesale change in the weather pattern, just like that does there. In fact, look, you can see the high pressure bias as it moves east, and the low pressure bias with its cloudiness and low pressure filling in to the entire Pacific starting 2 weeks, a week and a half from now, something like that. This is all very good news. All right, what's going on in the ocean? We're looking down in the ocean, not on the surface, but down, because remember, we've talked about Kelvin waves and the effect of westerly anomalies in the active phase of the MJO and its propensity to build Kelvin waves, and Kelvin waves being the gateway to usher in El Nino. All right, this is data from the TAO buoy array. Again, the West Pacific here, the East Pacific here. These are Lexes here. These are sensors on the anchor lines of the buoys. They help give us a profile of what temperatures are doing in the West Pacific. We want to see warm water right here, the 28-degree isotherm, 28 degrees centigrade. That's warm water. We want to see these lines here starting to slide off to the east. Now, the 28-degree isotherm, it hadn't moved at all in the past week. The 26-degree isotherm, if anything, it's backtracked a little bit. But the 24-degree isotherm has pushed well to the east and is actually getting deeper, suggesting warming water is pushing off to the east. Maybe a Kelvin wave. Let's go, but it's not the actual temperatures, it's the anomalies, differences from normal for this time of year. Now we see, if you recall, months ago, this whole area was filled with negative, -2, 3, 4 degree temperatures all in here. Well, look at this. There's a full stream of warm water that has made it into the East Pacific. Now, the main warm pool with 4 degree above normal centigrade temperatures has backtracked to, what is this, 150? Yeah, right there. 150 west. So basically south of Hawaii, maybe 148 or something like that. This looks like a Kelvin wave has pushed east, and the main warm pool, still holding pretty good almost halfway across the Pacific, is recharging a little bit. We know that there is westerly anomalies building strong right above here, perhaps imparting yet more warm water to this subsurface pool, and maybe it's going to spit out another Kelvin wave. Another version of that same model using different data, lots of warm water, much warmer. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 5 degree anomalies here, making it to about 150 west. The remnants of the previous Kelvin wave dissipating, weakening as they push into the East Pacific. The last little bit of cool water associated with the previous La Nina still lingering, and cool water here lingering at the surface. Let's go take a look at one other thing here. Upper sea level anomalies, the height of the ocean, the sphere of the ocean. Take out the waves, the wind waves, the tide. Is the sphere higher or lower than normal? Why do we care? Well, you can infer what's going on down deep in the ocean by the height of the sphere of the ocean. Cold water at depth contracts. When it contracts, the water above it will sink and create a little divot there. Okay. Likewise, warm water expands at depth. When it does that, it displaces water upward. You get a bump on the ocean surface. So what is this telling us? Well, let's see. Here is Chile, Peru. That's the equator right there. The Central America there. Hawaii, those little squiggly lines right there. Dateline there. Equator there. New Guinea there. Lots of positive anomalies. Very warm water all here in the West Pacific. But look at this. There's this path the whole way through here, 0, 0, 0, 0. This used to be filled with -5, 10, 15, even 20 centimeter colder than water, normal water off of, well, here's the Galapagos, all out in here this past summer. The past month, that's all just gone, and now neutral the whole way across. So here's another way to look at what that means. West Pacific here, East Pacific here. Blue, colder than normal water. This is at depth, down 300, the column of water from the surface down 300 meters, and much, much warmer than normal water here. In the West Pacific, and we're going back a year here. Notice, warmer temperatures just consistently building. Okay, last year about this time, we did have a Kelvin wave. It went the whole way across the Pacific. Warm water made it across the Pacific. But that was it. It kind of faded. Cold water rebuilt. Another Kelvin wave back in the early part of last summer. It faded. And then a massive cold response from that. Here is our latest Kelvin wave. Not as strong as either one of these twos, but it made it the whole way across to, as of right now, almost 100 west. So almost 80 west is Ecuador. So nearly there. And notice, warm water still building in the West Pacific. Some change is afoot. And you can see that change as well here. This is just the upper ocean heat anomalies from the date line over to about 100 west. Here's that first Kelvin wave back February a year ago. Second Kelvin wave in the early part of summer. Our big cool spurt. Now notice temperatures continuing to creep up. The question is this a one-time event? Is it just we're going to get a Kelvin wave and then we fall right back into one of these cool pools? Or is this the start of a wholesale change of warm water redistribution across the equatorial Pacific? We think that is what the case is, and that we are not going to fall back into one of these cool regimes after this Kelvin wave makes it across. In fact, we suspect that another Kelvin wave is developing right now from the active phase of the MJO that is pushing across the Kelvin wave generation area as we speak. So that would be, what was it here? February into July, one Kelvin wave every 6 months. This situation is now looking like a Kelvin wave pretty much back to back within a month or two of each other. So we will see. This is looking much more optimistic. Sea surface temperature anomalies. So we were looking down in the ocean. You know, there's things happening below the surface that you can't see, and then the effects of those once they happen, like once Kelvin waves erupt here off of Ecuador and the Galapagos, then you'll start to see warming in here. Right now we're not seeing it. In fact, the blues, the sea surface temperature anomalies, differences from normal for this time of year. You can see cooler than normal water still filling the equators, right? Let's do this. Chile, Peru, the Galapagos there, Central America, Hawaii there. The entire equatorial Pacific filled with colder than normal water, upwelling along the coast of Peru. But notice this, warming all off of Chile and just off the coast of Peru. This water here getting much warmer than what it was a couple of months ago. Little pockets of warming building here. The coolest of the cool water isolated to just this area in the far from about just around Hawaii on west of there. This does not look like a robust La Nina at all anymore. And what has the trend been the past 7 days? Well, this chart is pretty much unchanged now for a month, which is a good thing. South America, Chile, Peru, Central America, Hawaii, the equator right there, New Guinea there. The yellows and oranges, warming waters, and what we're really interested in is this area right here where all the cool water is at the surface. You can see it here, cool water here. What's the trend been? Well, still warming off of Chile, still warming off of Peru, pockets of warming along the equator, suggesting that the La Nina cool pool, this whole pool here, especially like in and around here, all getting steadily, slowly warmer. That is good news. And then the backed off view, you see it here too. Warming building off of Chile, Peru. Warming in this area. It's not warm yet, but the temperatures are not nearly as cold as they have been. The last of the real La Nina cool stuff is out here, and it's being driven by the trades into this big old warm pool here that's just going to vaporize it as it moves in there. And that's pretty much, we suspect, going to be the end of La Nina. All right, so we're going to look here. Let's pull this out of the way. September 1st, 2022. All right, so this is what we were looking at in September. Very cold water off the Galapagos, the whole way across the equator, filling this whole area. Cold water down the whole way off of Chile, Peru, the whole basic Pacific south of the equator, full of cold water. And then we look at where are we now? Look at that, warm water building there. This temperature's warming here. We'll go back and forth so you can just sort of see before, after, before, after, before, after. So, definitely an improving surface water temperature pattern. What does that mean? Well, that means that high pressure can't be fed. The cold water prevents evaporation, inhibits evaporation, and what you typically get over top of cold water is strong high pressure. Well, if you get warming temperatures, you get more evaporation. That then starts cutting into the high pressure system, allowing low pressure to form. And of course, low pressure is what makes our surf, our rain, and everything else. And so what is happening in California and across the North Pacific with the jet stream, all this makes perfect sense. Sea surface temperature anomalies. We're going to start in the East Pacific, the Nino 1.2 region, the area right there by Ecuador and the Galapagos. You can see temperatures up, maybe down a little bit just the past week or so, but still much higher than they've been in quite a while. Then the official El Nino monitoring region, the Nino 3.4 region, the area from south of California on the equator out to about the dateline. Temperatures starting to work their way up. Slowly, not too much, but trying to move in the right direction. All right, so what does the atmosphere think is going on? And this is the interesting part. If the water temperatures are warming, at some point, the atmosphere will respond and pressure will start dropping. So we look at the Southern Oscillation Index, the difference in pressure between Darwin, which is over the Indian Ocean, roughly the maritime continent, and Tahiti, which is clearly in the central Pacific. We look at the pressure between the two of those over time. If pressure is dropping over Tahiti and rising over Darwin, the index goes negative. Well, it isn't doing that today. It's at 22.15. In fact, it's been in the 20 range for, well, since December 17th. Now, the interesting part is, so we're saying westerly anomalies are pushing into the West Pacific to about 165 east, and the jet stream is raging. Why is this index not starting to go negative? And I think the key here is the position of Tahiti. Tahiti's at 140 west, which is even further to the east than Hawaii, right? And it's just literally, I mean, I'll say this kind of jokingly, it's a guy that goes out with a barometer and sticks his barometer up in the air every day in Tahiti. It's more than likely an automated machine, but it's still located on the island of Tahiti, 1,000 miles or more further east than where those westerly anomalies are pushing. And clearly, the westerly anomalies in the active phase of the MJO are having a significant impact on the atmosphere because the jet stream is just out of control and the weather in California, that's all driven by that. This index is not sensing any of that, and I think it's just because of the position of where Tahiti is. As the pattern builds, if you looked at the models, we talked about it building over the entire equatorial Pacific come late February, early March. At that point, I think you're going to see this index starting to collapse and collapse really fast. But for right now, it's positive, has been positive for quite a while. The 30-day average, 21.05, actually going up rather than going down. Again, we think there's this wall between where the westerly anomalies and the low pressure is in the far west Pacific, and just on the other side of that wall, there's stronger than normal high pressure, and I think Tahiti's just sitting right in the middle of that bubble. So this index really not doing anything for us at the moment. Once the wall of westerly anomalies push well over the date line to a point north or a point over south of Hawaii, then I think you're going to start seeing a change here. Anyway, the 90-day average, 14.05. Where is that? Well, basically, it hasn't changed in a month. Interesting, because the whole rest of the North Pacific is on fire, and this guy's completely blind to all of it. And the 30-day moving SOI, just graphed out so you can see it. Well, it's up as high as it's ever been during this La Nina event. We think this is really the calm before the storm, though. And as soon as the wall of westerly anomalies makes it deeper into the West Pacific, you're going to see this index just crash down way below where this is, probably down into the -10 range. And then you can clearly say, okay, El Nino's on its way. All right, so what's going to happen? We're just conjecturing here, but what do the models say is coming? Right, since we're running a little bit long here, we're just going to go right to the PDF corrected version of the model. This is the best, most accurate version. This is sea surface temperatures for the Nino 3.4 region, the official El Nino monitoring region on the equator. Again, that area from south of California on the equator out to about the dateline. Temperatures about 1 degree below normal through January 15th. And then temperatures forecast to creep up to half a degree below normal in the El Nino monitoring region. The Nino 3.4 region is considered normal between here and here. That's half a degree above. Once you get more than half a degree above, you're in El Nino territory. A steady warming is forecast and has been forecast for months. Those of you that watch this every week, you know this is like watching paint dry. It's the same old broken record. The change is coming. We believe it's coming. Everything seems to indicate that it is coming, that La Nina is all but dead. We see the foundations of it being completely ripped apart now, and water temperatures neutral in a month, maybe even less, and then dead neutral at 0 as we get into April, and bordering on minimal El Nino territory as we get into the middle of summer, starting to approach fall. This is exactly what we were hoping for. All right, so really good things are happening in that months ago, the models, most all the models, were suggesting a major change was underway. La Nina was going to die. The westerly anomalies were going to start building in the West Pacific, and that perhaps the jet stream might finally wake up after being asleep for 2+ years. Well, in the past couple of weeks, all that has come true. Not exactly as modeled, but probably within a week or two, and actually the transition has been far more dramatic than we ever expected. I mean, the jet stream change right before Christmas, and the massive amount of energy that has been pushed into California, not only just, I'm talking latent heat energy and rain and snow. I mean, from a snowfall perspective, the Sierra is probably at 70% or more of their normal total annual depth, and we're the first week in January, with months still more to come. Now, we do see a change in the jet stream about a week out, and things will moderate some. We think that the active phase of the MJO has really driven a lot of this activity. That said, it's not just the active phase, because we've had multiple active phases in the past and not seen, in the past 2 years, and really not seen anything near like what we're seeing right now. So it's the mixture of the change in westerly anomalies wholesale over the West Pacific, enhanced by the active phase of the MJO, pumping piles of energy into the jet stream, feeding the storm track, doing all the good things and some bad things that we've been talking about through the past hour. And we expect that to continue for at least another week. Then somewhere mid-January to later January, things will mellow out a little bit. We get a chance to dry out, damage repair, road repair, mudslide repair, all that sort of thing. And then probably as we get into mid-February, round 2 comes up. So hold on to your hats, because by then westerly anomalies will be even more entrenched in the West Pacific, and the potential for yet more rainfall and damage is possible. Not saying it's going to happen, but it is possible. So just be mindful of that. All right, but all this is in getting us in a much better place than we were a year ago, 6 months ago, even 3 months ago. Dramatic wholesale change. The pattern looking much more like a quote-unquote normal winter for California. Hawaii, maybe not so much. The focus has been really on the East Pacific. We think as the jet stream splits, Hawaii will be in a much better position. The dateline area will really open up, and the storm pattern will be focused there. And that actually is better surf-wise for California. All right, so things moving in the right direction and right on track, just the way we wanted. That's it for this week. If you enjoyed the video, give us a thumbs up, like and subscribe, ring the bell, all those good sorts of things. If you have any questions, write them down. We'll be happy to answer. We try to reply to all the comments. All right, that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.